In the previous lesson, we learned about special right triangles, and I told you in class that special right triangles was another way to help us find missing lengths of right triangles. So far this year, we have learned two different ways to find missing lengths of a right triangle, one of them being Pythagorean theorem, and the other being special right triangles. Now, each one of those has some issues. Pythagorean theorem only works when you know two of the three sides of the triangle. Special right triangles only works when they are two specific triangles, 45, 45, 90 or 30, 60, 90. So what we learn then is there's actually a third way to find missing lengths of a right triangle, and they can be used in any case. And that third way is called trig ratios. So there are actually 6 trig ratios. For our purposes in our class, we're only going to learn 3 of the 6. The first one of being tangent ratio. So the entire rest of the unit, what you need to understand is that tangent, sine, and cosine are just a ratio between legs or hypotenuse of a right triangle. So, for example, tangent ratio is always opposite over adjacent. Okay, so what you're going to do first is you're going to identify which angle you're trying to find tangent of. In this first case, you're trying to find tangent of angle A. So I usually circle the A, and then I label the sides based off of that angle. The side on the opposite side of the triangle is called the opposite side. The side directly next to the angle is called the adjacent side. And the hypotenuse is always called the hypotenuse. So if I wanted to figure out what tangent of A is, all I'm going to do is write a fraction. That fraction is going to be the opposite side, in this case, is labeled with a little a, over the adjacent side, which in this case is labeled with a little b. Now, as we move through some problems and you have some numerical values, it's going to be a little easier, I think, for us to understand what I mean by tangent is just a ratio. So we're going to skip the first problem and just look at 2 and 3. In number 2, it says find the tangent of angle R. So what I'm going to write down is tan R, and I'm going to circle the R. From the R, the 3 sides of the triangle. The 8 is the opposite side, the 6 is the adjacent side, and the 10 would be the hypotenuse. For tangent, it's always the opposite side over the adjacent side. So in this case, the opposite side is 8, and the adjacent side is 6. So for tangent of R, we have a ratio of 8 over 6. That can be reduced, so we would say that our tangent of R is 4/3. The problem also asks us for the tangent of angle S. So let's change our perspective. Now S is in the bottom left, which means that the sides that are labeled in my triangle actually flip-flop. So the side opposite of the S is now the O, the side next to it is the A, and the hypotenuse is still the hypotenuse. So to figure out what tangent of S is this time, we're again doing opposite over adjacent. The side opposite of the S is 6, the side adjacent is 8, and so if I reduce the ratio, I get a tangent ratio of 3/4. We're going to, in the next one, just focus on tangent of S. Tan of S here, if we label our sides, the side opposite is 10, adjacent 24, hypotenuse 26. So if I want the tangent of S, it's opposite over adjacent. So the fraction 10 over 24. Again, anytime we have a fraction, we should reduce it if possible. This one reduces to 5/12. What we can do is we can use the tangent ratio to help us figure out missing lengths of a right triangle. So what we're going to do here is identify first where the angle is, and then we're going to identify the side lengths that are labeled from that angle. So in this picture, the 3 is the opposite side, and the x is the adjacent side. So anytime I see O and A, opposite and adjacent, I know I'm going to use a tangent ratio. So tangent of 22 degrees is equal to the ratio of 3 over x. Now anytime we solve a problem like this, if x is in the denominator, like this one currently is, then we are going to use division to solve the problem. So we are going to take 3 and we're going to divide by tan of 22 degrees. This is going to come out a messy decimal, so we're just going to round the decimal to 1 decimal place. Now, if I pull up my calculator, I can do a fraction, so 3 divided by. If you're using my calculators out of my cabinet, there's a trig button on those calculators. Notice it's highlighted in red right now. And I can select tan from the list, and all we're going to do is type in 22. If I push enter, it should give me an answer. Now there's a problem with this answer that I should have taken care of previously. So I'm going to fix that problem very quickly, and then I will be right back to tell you what the actual answer is. Okay, so if I retype what I just typed, I fixed a setting in my calculator, and it should now give me the correct answer. So I'm just going to retype, and there's my answer, 7.42526. So going back to my picture, rounding that to the nearest tenth, which is 1 decimal place, that would round to a value of 7.4. That's the length of the missing side of that right triangle. Same thing's going to happen again when we do the next one. I'm going to first circle the 35 degrees, and then I'm going to label the sides. The 4 is opposite, the x is adjacent. Anytime I see O and A, we're going to use the tangent ratio. So tan of 35 degrees is equal to the ratio of 4 over x. Since x, again, is in the denominator, we're going to divide in order to solve the problem. Made a mistake. We're going to write it as x equals 4 over tan of 35 degrees. And again, if I want to figure out what it is, all I have to do is go to my calculator, type in a fraction, 4 tan of 35, and we would round this decimal to the nearest tenth, 1 decimal place, to 5.7. So we would say that x is equal to 5.7. Now, I believe that the paper I gave you has the next problem mislabeled. So if you would, I believe on your paper, this up here is the 18 and this here is the x. If you would, please change it so that it looks the exact same as mine, that would be great. So I'll give you a couple seconds to do that. Okay, so please make sure your picture looks just like mine. So when I circle my 55 degrees, the side with the x should be the opposite, and the side with the 18 should be the adjacent. Again, tangent ratio. So we're going to do tan of 55 degrees equals opposite over adjacent, so x over 18. Now notice the setup of this problem is a little different than the last two. In the last two, the x was in the denominator, and we divided to solve. This time, the x is in the numerator, which means that we're not going to divide to solve. We're actually going to multiply to solve. So instead of doing 18 divided by tan of 55, like we did in the last two problems, we're going to do 18 times tan of 55. So I'm going to bring up my calculator so we can do that calculation. 18 tan of 55. And we end up with approximately 25.7. And that's my missing side length. On the back of your sheet, we start talking about two other trig ratios. They are called sine and cosine. Now, tangent involved opposite side and adjacent side. Sine involves opposite side and hypotenuse. Cosine involves adjacent side and hypotenuse. So I have an acronym that we usually use. You'll probably hear me say this a lot. And that will tell you exactly which trig ratio you're going to use depending on the side lengths that you have. SOHCAHTOA. So the SO portion represents sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's what SOHCAHTOA means. So in the bottom problems down here, notice the first one says find sine of B. So from B, I'm going to label the sides. The 6 would be opposite, the 8 would be adjacent, the 10 is hypotenuse. From above, when we do SOHCAHTOA, sine uses the opposite and the hypotenuse, which means in this case, I would be using the values of 6 and 10. Reduced, my sine ratio is 3/5. If I want the cosine of B, we don't use opposite and adjacent, we use adjacent and hypotenuse. So adjacent in this case is labeled as 8, hypotenuse is 10, so we have a reduced ratio of 4/5. So what we can do is we can use a sine and cosine ratio to solve for missing variables just like we could with tangent. So in each case, we're only going to find one of the variables in each case. So I'm going to scratch out some of these. We'll scratch out that one, and let's scratch out this one. So in number 6, the first thing you do is circle the angle you're given, and then label the side lengths that you have stuff on. The A is on the opposite side. The 7 is on the hypotenuse. So if we're going to use a ratio, O and H, according to SOHCAHTOA, O and H tell us that we're going to use the sine ratio. So sine of 34 degrees is equal to A over 7. Just like with tangent, depending on where your variable is, this case in the numerator, it will tell you whether you're supposed to multiply or divide. Since the A is in the numerator, we're going to multiply in order to solve for my variable. So again, going to go to the calculator. We're going to say, 7. This time we used the sine ratio, and I believe it was 34 degrees. So we're going to type in 34, and my missing side length in this picture, 3.9. So I'm going to copy that down. A is approximately 3.9. Oops. In the next picture, first thing you want to do, circle the angle, and then label the side lengths. The 5 is the hypotenuse because it's across from the right angle, and the B is your adjacent side because it's next to the angle that I circled. According to SOHCAHTOA, anytime I have A and H, we're going to use cosine. So cosine of 43 degrees is equal to adjacent side over hypotenuse, so B over 5. Again, notice your variable is in the numerator, which means we're going to solve using multiplication. 5 times cosine of 43 degrees. That again is now just a calculator problem. So we go to the calculator, 5 cosine 43 degrees, and we push enter, and it gives me approximately, rounded correctly, 3.7. In the last problem over here, again, the first thing you're going to want to identify is where my angle is, and then label the side lengths that you're given in the problem. The A is your opposite side. Your 10 is your hypotenuse. Anytime I have O and H, we're talking about sine according to SOHCAHTOA. So I do sine of 32 equals opposite over hypotenuse. So in this triangle, A over 10. Again, noticing that the A is in the numerator, so we are going to use multiplication to solve for A. 10 times sine of 32 degrees. So again, we go to our calculator, and we type in 10 sine of 32, push enter, and we get approximately, if rounded correctly, 5.3. And that's the missing side that you were being asked for. Okay, so again, previously we had learned that Pythagorean theorem helps us find a missing side of a right triangle, but it has a stipulation that you have to know 2 of the 3 sides. That's not always the case. All of the problems we've talked about in this video, we didn't have all our 2 of the 3 sides. We only had 1 of the sides. So Pythagorean theorem wasn't going to help us in those cases. Special right triangles you can do when you only have 1 side, but they require that the triangle's angles are 45, 45, 90 or 30, 60, 90. In none of the problems that we talked about in today's video, none of those problems had those specific angles, so special right triangles wouldn't work. So the third way we can find missing lengths in a triangle is using sine, cosine, and tangent, so our trig ratios. Now, all of the stuff we learned about today are specific to right triangles. So you can use trig ratios in any right triangle, and that will help you find the missing parts of the triangle. There's a lot more to this. Notice we skipped the word problems. We're going to spend a whole day talking about word problems and what the meanings say and what the pictures are supposed to look like. We're going to do all that kind of stuff together in class, so don't worry about the word problems. If you can walk away understanding numbers 6, 7, and 8 that we did in the video, and understanding what we did here in 6, 7, and 8, you'll be good to go. If you have any specific questions, make sure that you make note of them so you can ask me about them in class.